Hello guys, what's up? We are back again with another question from our DSA challenge series. So let's get started. So guys, today our question is path with minimum effort. And this question states that we are given a 2D array, which is named heights, and we need to travel from 0, 0 top left cell to the rightmost bottom cell, row -1, column -1. And we need to find the path which takes the which has the maximum absolute difference in heights between the two cells as the minimum. Okay, so what does it mean? For example, in this, if I take this path 1, 3, 5, 3, 5, then maximum absolute difference between any two consecutive cells is 2. That is 1, 2, 3, or you can consider 3 to 5 or 5 to 3. But if I take this path 1, 2, 2, 2, 5, then maximum absolute distance between any two consecutive cells is 3, 5 minus 2. So we can't take this path. So this is the question. We need to take the path which takes the minimum maximum absolute distance from all the paths. So when the statement says that you have to take all the paths and some minimum paths, so something like Dijkstra comes to our mind, and we can use that only in this question. So we can have a priority queue in which we will store the maximum absolute distance and the current cell location. Okay. Then we can have a distance array initialized with 1e9. Now we will perform the Dijkstra. So we will first insert the source node, that is 0, 0 into the priority queue. And then we will start with our normal Dijkstra. Now at any moment if we reaches our destination, then we will return the difference which we will be having in this, which will be having at the top of our priority queue. Now, in order to iterate, we know that adjacent neighbors will be either column +1, column -1, or row +1 or row -1. So we can use this very standard logic of having two rows to erase dr and dc and calculating the new row and new column and iterating to the adjacent cells. Now here comes the bit. Now, if the maximum absolute distance, between the row and the new row is greater than the difference which it already having, which it is already having, then we will update. Then we will update it. Cool. Now, then we will update the new effort variable. But if the new effort variable is less than the distance, is less than what is there in the distance array of that particular new R and new C, then only we are going to push it back into the queue. So if it is maximum, as well as it has to be maximum absolute distance, as well as it needs to be less than the distance of new R and new C in order to go into the priority queue. Fine. So this is what will happen. And so for every index, we will store the minimum possible maximum absolute distance to the path which it has covered. So yeah, guys, this is how, and we can finally return distance of n-1, n-1 if this doesn't execute midway. So yeah, guys, this was all from this question. Thank you so much, guys, for watching this video. Just in case you like the video, like the question, make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.